Hi, we're the NASA Psyche Capstone team, a multidisciplinary senior design team at the RIT Kate Gleason College of Engineering. I'm William, a computer engineer and the project manager for the team.
I'm Elliot, I'm a financial manager and another computer engineer for the team.
I'm Madeline, the researcher and tester. I'm a biomedical engineer.
I'm Tony, a mechanical engineer and facilitator for the team.
I'm Max, I'm the hardware manager and also a mechanical engineer.
And I'm Alex, the CAD designer and also a mechanical engineer.
The Psyche asteroid is a metal-rich asteroid orbiting the Sun at 235 to 309 million miles. Psyche is an M-type asteroid discovered in 1852 by Italian astronomer Annibale de Gasparis. The Psyche asteroid is of interest due to its partially metallic composition, indicating that it may be the remnants of an early planetary core. Planetary cores have never been able to be studied before, so this would provide novel insight into planetary composition and accretion. NASA launched the Psyche spacecraft on October 13, 2023, to orbit Psyche in July of 2029. This is NASA's first mission to study an asteroid that likely has more metal than rock or ice.
We are working with the NASA Psyche Mission Capstone program, led by Arizona State University, to create a device for potential far future exploration to collect samples from the surface of the Psyche asteroid. Our team hopes to create a device to collect, sort, and store particulate samples.
The approach we went with starts with lowering a mechanically actuated claw down to the asteroid surface, and then the sample is collected with buckets. Next, the bucket assembly is positioned above the sample collection container. The sample is then dropped above the sample sorting funnel, which discards the larger grain material back to the surface and allows the smaller grain material to fall through into the sample container. The sample container itself is a drum with 5 test tubes that rotates and positions each test tube under the funnel to collect multiple samples.
We utilized an Arduino Uno version 3, 3 stepper motors, 1 servo motor, a wiring kit, and a DC power supply to control and power the movement of our motors. We use the CNC shield on top of the Arduino to control each of the motors and a plaintext user interface over a serial connection to control the movement of each motor. An infrared sensor was added to the bottom of the claw's base and connected to the Arduino.
Our team expects to have a partially automated device that is capable of collecting material off the ground, removing large particulates, and safely storing the samples. There will be motors that can control the movement of each subsystem, and a sensor to prevent the device from hitting the ground and becoming damaged. This will result in a filtered sample safely stored in the storage container that can be analyzed and/or sent back to Earth for analysis.
We'd like to thank our sponsor, Dr. Cassie Bowman, for giving us invaluable feedback on our project, our guide, Dr. Alexander Louie, for giving his guidance along the way, and the RIT MSD department for tools and materials.
Woo!